World. I'm Martin Rhode. I'm here at a table with Sebastian from Rhode and Schwartz, and we are at the NYU Brooklyn 6G Summit 2023. And Sebastian here has got a setup where he's got a neural receiver and he's doing some training to get the receiver so that it will work better. So, Sebastian, why don't you give us a little bit of a background of what you're doing and explain this?
Yeah, sure. So we have a neural receiver that actually learns to do channel estimation, equalization, and demapping jointly together. So we take a single neural network that replaces all of these traditional signal processing blocks and is kind of trained to output log likelihood ratios for the transport block decoder, essentially.
Okay.
And in this demo, we go one step further. We now also make the transmitter trainable, so we learn custom constellations. So we learn a new QAM scheme, essentially. And,
you say a custom constellation, is that based on channel measurements or a channel characteristics?
So this is actually a joint demo between Rhode and Schwartz and NVIDIA. And at NVIDIA, we have a software that's called Shona. So that's a channel. It's a prototype, a link level simulator, essentially, a machine learning support, and it's written in Python TensorFlow. So what we do is we can use the channel models from Shona to generate synthetic data. So we do the training for a synthetic data set, essentially.
Okay.
And that allows us to kind of generalize or randomize, essentially, the channel. So we train the system for a huge variety of different channel realizations, and then later when we deploy it, we just fix the channel for the over-the-air demo here.
Okay, thank you. And now we've got some test equipment here, and Andreas from Rhode and Schwartz is going to explain how the test equipment works.
Yeah, thank you, Martin. So basically, like Sebastian said, the curves that we see are simulated, and the goal is now to verify the performance using test equipment, right? So what we're doing on the left-hand side is basically now emulating the user equipment, the device, where we generate a standard compliant 5G NR signal with the difference that we can now use the learn custom constellation and generate a signal accordingly. So we basically generate the signal, receive the signal, and then transfer the IQ samples over here to the workstation, do some pre-processing on it, and then feed it into the new receiver model that NVIDIA trained with the Shona software. And what you actually can see now on these simulated curves is these blue dots. And the blue dots basically mean now we generate the signal with the custom constellation, we add a fading profile to it to emulate real channel conditions. But now at discrete SNR steps, we send a couple of samples, process them, and then validate this measurement at a transport block error rate. And as you can see very nicely, that the blue dots follow that simulated curve precisely, which means that actually the performance that we show with the new receiver can be validated in a hardware-in-the-loop experiment using actual test equipment from Rhode and Schwartz.
Okay, now this constellation that you have here, we're used to seeing where you want to see a nice square constellation with very fine dots, and yet here we have something that's based on measurements that you've done on a channel. And yet this is not a constellation that we're used to seeing. So what's different about this?
Yeah. So basically, what we learn here is the best trade-off on how the signal would cope with these channel model, right? Mm-hmm. So it has been trained on the UMI channel model from 3GBP with a randomization of Doppler shift and Doppler spread, so that we can use it under various channel conditions. Yeah? And that is basically the best shape that the model learned. And the beauty of that is, if we just click here for a moment, that we combine that also with pilotless communication. So today we need pilots in the constellation, so that the receiver knows exactly what to look for. So this is gone now, so we create a performance gain that way. And you can see this constellation shape as its own pilot sequence, right? You see a little bit the outlier here on the top. That is what the receiver was trained for, can look for, and that's why we don't need any pilots in the communication signal, which is a change from 5G to 6G that it eventually will be adopted in that particular setup.
Very good. Thank you, Andreas.